Alright, so here is going to be the solution to homework number 10, problem 1. And we have a beam here, and it's got the dimensions or 4 feet, 8 feet, and 6 feet, with a load here at A of 450, a load at B at 300, and a load at C at 700. It also has this moment applied to it of 1,500 foot-pounds. And this is 60 degrees, and this is 30 degrees. And we want to determine the magnitude and the equivalent force, and its the magnitude of the equivalent force and its point of application on the beam. Right. So we just want to have a single force that gets applied to this beam. So let's bring this over here to this other side and take a look at our camera here. Okay, focus. And this is spring of 2021, and we are in ES110, and this is homework 10. Starting to regretting making so many new homework problems, but that's okay. Let's draw this thing out. I'll use a straight edge, why not? And put these on here. Let's see, it's got a little connection right there. It's got a little roller ball action right here. Right here is a force at A, and this is A. This is B right here, and FB, and we have FC. This is theta C. This is point C. Here's MC, and the distances. I forgot to put in my theta A. Distances. Get lazy and put a line all the way through. Erase, erase, erase. And I guess this is O. And so this is XOA. And this is XAB. This is XBC. Here's our given. We're going to say that XOA is 4 feet, XAB is 8 feet, XBC is 6 feet, FA 450 pounds, FB is 300 pounds, FC is 700 pounds. There's a lot of information here. 1,500 pounds. Theta A was 60 degrees, and theta C, there's no theta B. Theta C is equal to 30 degrees. And our we want to put the magnitude and location. Yeah, magnitude and location. Equivalent force and location. So we want a single force. So what we do, let's take the find the resultant that we would have from all these forces. Some of the forces right here. So I'm going to do this as unit vectors. I guess I'll do that. So let's see. We're going to have, this is our 450, right? And that's our 300. And then this is our 700. All right. Okay, so 450 times the cosine of 60, yeah, okay. 60, and then Here's going to be minus 700. And that'd be the cosine of 30, I guess. No, sine of 30. Alright, that's I. And here we're going to have a negative 450. I don't know if I'm going to leave enough room for myself. And the sine of 60. And then, yeah, we're going to have a negative 300. And then we're going to have a negative 700. And that's going to be the cosine of 30j. So, seems like my desk is getting smaller and smaller here with all the crap on it. And what are these horizontal lines on this thing? I want to know. I think it's from the camera. I asked Dr. Asaki, and he said it was just because it's a terrible camera. That's what he said. Cosine times, alright, and then sine of 30, yeah, from 700 minus, whoops, I was dumb, 700. So we get a minus 125i plus, let's see, 450 times the sine of 60, and the 300, and then 700, and doing the cosine here. So we get a negative 1,296j, and these are pounds. All right, so this is going to be the force. This is going to be the answer to the equivalent force. But now we need to figure out where it's going to, where we should put it. So here's what we'll do: is we will take the sum of the moments, and let's take the sum of the moments about O. Right there, right? So we could do this in a couple of ways. We don't want to do the cross products. All right, so we'll just add them up. So remember that counterclockwise is positive. So let's just go ahead and add in this MC right here, but he's negative because of the direction he's going. And so it's going to be 1,500. And then we'll start with here. We'll go to FA is going to cause clockwise. I think everybody's going to cause clockwise. Yeah, everybody is. And we can actually just take like all of the, each individual one of these right here. So it's going to be clockwise 450 times the sine of 60, but times our XO right here, which is, this is 4 feet, 8 feet, and 6 feet. So we can just look at that right there. So this is going to be that times our 4 feet. The next is going to be our 300 times, what's that, 12 feet? Okay. And then lastly, we're going to take our 700 times the cosine of 30, and we're going to multiply it by, was that 18? Yes, 18. Once again, I don't like these kinds of problems because we're ignoring that there's forces right here underneath there that are supporting this thing, but this is just this imaginary thing that they're trying to do. Right? It's a concept thing, and I prefer to have real scenarios as opposed to just these. It's an educational thing. I don't care, but okay. Times 4 times, right? So then we have 312, right? And that gets there, and then 700, and the cosine of 30, and then multiply that by 18. Boom. So we get something large. We get 17,570. Whoops. foot-pounds. And now, so what we want to do is we want to find out the location that this would need to be placed. But it's only this guy that we really care. So all we wanted to do is find out the X location right here. So I don't think there's any slick way maybe of writing this out, much less than just the X right here. Is this going to be the M divided by the F? What I'll say is the F and the Y right here. So this is going to be the distance from O that we're going to get, right? So 17,570 divided only by the Y component right here, and by the way, it's going to be negative. So we could even say that these are both negative if you wanted to, but I'm not going to bother, right? It's part of the thing, and so just directly in my calculator, I just hit divide, and so this would be located at 13.56 feet. All right, so the answer is the resultant force should be negative 125.0, which we're assuming this beam's width doesn't matter right there. Okay, just we're neglecting it. And negative 1,296 J pounds located at X equals, I guess I'll call it XO, X2056 feet. And there you go. Looks like I'm like in a some with the stripes on there. I don't know. I wonder if this shows that stripes. Those stripes must show up on the video, but the stripes make me think of like being in one of those noir type of detective movies. I don't even know what noir means. I think it means like a dark or something. Like it's a dark. I don't know. Film noir, Noir. Look it up.